let's go. It's just extremely hot in here. We just used the oven for quite a while. Usually I'm okay. It's a little hotter in this room than normal because of the oven. We did make an absolute delicious dinner though. So basically we made tacos, but yeah, okay. Your computer probably is very warm then. Um No, that's not how we do this. We do this and then that. That's the formatting we've chosen. Okay, so we made tacos. So like you just make the inside of the taco, but instead of putting it in a tortilla, just put it in a hollowed out zucchini, more or less. But you know the zucchini ends up, you have to bake the zucchini for quite a long time, 10 minutes before. So you scoop out all the stuff and you mix that in with your taco mix and then fill them and put cheese on them and bake them. Super good. Highly suggest. Yeah, it was delicious. Probably better than a regular taco for me. So this is given to us, and then we're going to implement, although I can probably do this myself, right? I know how to do this. Maybe. Why do I have one letter parameter names? These? I guess I've always had one like, because this is not Java. That's like just Haskell. Nearly everyone writes this like this, so I just kind of follow along. I would generally argue that if you look at Haskell code, you're going to see this way more often. I mean, I don't disagree that it's not descriptive. I don't think it's completely it's not descriptive because it's just one letter, but it's it's so common that I think we should probably leave it this way. I mean, I don't know that I am, but oh, right. We're gonna we need to form a function where we're gonna take I don't like this already. I want to call this SA. Mm-mm. So my brain for whatever reason was reading this backwards. So I was thinking I'm doing something and this was my like these were my bindings and then this was somehow my solution, but it's backwards. It's the other way in Haskell. I'm not sure why my mind was doing that, but it was. Why is my formatter not doing anything? It's just not doing anything. But okay. Yeah, so this looks fine. So okay. So we need to get to this. Applicative. So we're going to be given an x, which is an a, and we need to embed it into state, which means we're going to take s2 xs. And we need to have functor sure. Something like this. Oh well. Also, since I don't want to forget this, we got another followable rig on. So odd melon. I'm gonna go with odd melon. It's kind of fun to say. I'm not sure who that is. Hopefully they'll come hang out at some point and tell us if they're a Haskeller. And I also figured out the issue with the subscriber goal thing. So the subscriber goal thing is actually correct now. So this should just be that. Yes? Yeah, and then we need this. Nothing happens. It's just like I'm trying to just put goals on the screen because apparently people will just like help you with them. So that's kind of what I'm doing. So the goal is let's get another subscriber, and it's basically always going to be that goal. And if we go down, we go down. If we go up, we go up. I'm not too worried about it. I'm going to use, well, as we talked about it before, I'm going to use any money that I get to just put it back in the stream. So the first plan is to get a new chair because this chair sucks. Okay, so now we are going to need to make a state. And we're probably going to need something like this. But we probably want a pattern match on this. Maybe we even want a pattern match on this. Oh, but I don't need these parentheses. Okay. Apparently I haven't done this in a while and my brain is completely dumb. So let's go remind ourselves what we're supposed to be doing. Okay. This doesn't even show the types. Useless. Here we go. All right, so I got a function that takes me from one state to another, and then I have a functor of state. Oh, right. This is actually not this. It's really an FAB. Let's use FAB there. And this is a S to AS. Okay, so what's the correct order? The correct order is I need to get the A from the first state, transform it, and then embed it in a new state, right? So this will get me the first state, and then I need to transform A and stick this prime back in there, right? I think that's right. But this is not going to be the right shape, so bear with me. Ah, right. So this thing needs to be given S prime, and then when it has S prime, it makes an A. And when it makes an A, we can convert it. No. Wait. I'm so confused. I needed to write some types out. Okay, so it usually makes sense after I write the types out, so. The problem will be, am I getting the order correct? Because to pass the rules. We could test the rules if we wanted to. So if I give let's expand this a little bit. So we're gonna put this down here and this here and that there. We can do multiple lets here, right? So the first thing we need to do, I think we have to do the fab first. So we're gonna get f right, and then s prime did you say that before I started this? Or am I misunderstanding? So then I just need to do fxs double prime. Yes? I think this is what you mean. Okay. Yeah. The only thing that I don't remember is if this is the correct order. But if I remember, probably. Oh, that's okay. You're probably right. It's more consistent that way. Okay, neat. And I think it's even correct, which is good. Once I realized this shape, right, that's the key. So you got to realize this shape. You need this F. And once I realized that, it was totally fine. Yeah, in this case, luckily I'd only need one F. But really, this really is not FAB, right? If I was calling it what I normally call it, it'd be called SABs, just because I tend to just write the order of the characters I see. That's just a habit. Maybe it's not a good one. Uh, yeah, I mean, I see where you're coming from because I know you well. I don't you write Haskell as well as F sharp or C sharp, so I think your naming conventions are probably different than the way sort of typical Haskellers would name functions and things. Yeah, I think that the key point of this is really that in the wild, this is what you're going to see, right? You're not going to see state 0, state 1, function A to B. Yeah. World's Ender, by the way, hi. I feel like I haven't seen you in a while, but maybe you've just been quiet. Um, Let me read this. Note, you can recover the monad instance from just the two functions a to s to as and s to a. Similarly, you can recover the applicative instance from s to unit s, and that's hard to read. You can recover. What does you can recover mean? Oh, like if you just define these two functions, you can use them to define monad and the applicative and monad more easily. I think that's what you mean. We are weird. That's for sure. World's Ender, could you just show me one example of what you mean? Do you mean is what I said correct? Just define these functions and it should be easier to define these things? I mean, I can probably try it. I just want to make sure I'm comprehending what you're saying correctly. Because I'm probably not. If we're being honest with ourselves. Maybe chat's slow. We'll get there. Okay, I'll just keep going. I don't think I'm dropping frames or anything, so PC looks okay. All right, so it would be nice. Okay. Do you think it's worth trying? If you think it's worth trying, I'll do it. I'm not scared. Okay, so we need to go copy these signatures. Excuse me. So this looks like, I mean, this is just I can't type. I try not to, Newmade. It's very hard sometimes. I want to fear things because sometimes I go down paths that are not ideal. S-A. This one is S-A-S-A, I think. And then I think this one. And this complicated one. Okay, let me scroll back down. Are these listed somewhere so I can look at them? Just to make sure they're correct, or you can just check them real quick and make sure they're correct. Got it. I see it. I see what you mean now. I misunderstood at first. I got it. And well, this one makes less sense. Yeah, yeah. I understand this one. This one must be a tuple though, yes? Unless I copied it wrong. Yeah, the only one I want to make sure is correct is this one. Okay, let's check this one. SAS. Okay, wonderful. So SAS, SBS, S. I understand it's hard to write this in Twitch chat, so I appreciate you guys bearing with me while I'm getting this correct. So this looks correct, yes? Oh, let me move my cursor. I think this is right. So this one's easy because this is just that operator. At least I'm pretty sure it is. Yeah, it is. Okay, so this one is like some sort of application. We're just taking this S and applying this function to it. We've probably seen this before. Let me Google this because I feel like this is something we've probably seen before. But it's not immediately jumping out at me. Because it's like F. Yeah, F-A-A. Well, no. Anyway. It would be B in that case. Oh, this isn't a thing? I mean, we can just put an F here. Okay, fine. Okay, so you read that as follows. Your state function, state A, S to AS, right? But actually, it is a composition of two functors. We have applicative A equals S to A, and tuple A, wait. Oh, an app functor and a tup functor. Interesting. Okay. How do you pronounce app? Because I wanted to say applicative. Do you just call it, is it like apply? I'm not really sure what the right terminology is here. Or are they just some arbitrary names that you decided? Okay, anyway, we can write these functions. So I keep wanting to write apply, but that's probably not a good name, but let's go there. Yeah, I think it's just a data constructor, but I'm wondering if those names were chosen for a reason. I think because like the code I'm looking at here is like kind of pseudo Haskell, so I'm just making sure I understand. Okay, I'll look at that in a second. So this is like, that's a very funny definition. Oh, I see. Okay, so this comes probably from uh, category theory or just math, something like this. Okay, so then I need to think. We'll implement these functions, and then I need to think of um, how I use them for what you're suggesting. We'll see if I can do it. So this one is like, I don't know what to call it. We'll call it that for now. Oh, right. Wait, both of these produce a new state, so which is the state I'm supposed to embed? Well, actually, it did this last time, so let's do this. Because you're going to have, like, A. Probably do it like this. Is... No, never mind. Ignore me. Or am I supposed to give this as 0? Probably. Redundant lambda. How so, Haskell? How so? Well, really, how so? Applicative does not tell you the order, doesn't it? I guess not. That's actually a good point. Wouldn't... Okay, so yeah, I guess that's right. So for a particular instance, you could choose based on the state, but it has to be consistent each time, right? Like you can't say one time I'm going to take it this way and another time I'm going to take it another way, right? Wouldn't that be unlawful for applicative? I'm not sure what law it would break. I'm mostly just curious. What is this telling me? Oh, sure. Okay, fine. But doesn't that affect the resulting state? Like if you arbitrarily pick one, doesn't that affect this? I agree with you that if there was no state, then that's why applicative could be parallel, but I'm a little confused at how this could be lawful if you flip, like if you just return S0. Well, I guess you can't return S0, can you? You have to make B S0, A S1, and then it's S1. Just the order changes. I see. But the state is not the same, I presume, if you do it that way. Is that correct? I'm rambling, so I understand this is probably not very useful to you. I'm trying to justify it to myself in words, but it's not working. You're probably going to type something long, so I appreciate that. I will wait for it. Okay. So now we need to add some notes here. So we need to go back to here. So let me get rid of this because we already have those written. So equivalent to state okay, I think that state A is equivalent is the same thing. So you can write equivalent to A to app top A. Data app. Give me a second if you're typing. I just need to find these. App A. Top A. Okay. Oh, what's going on, Oren? How are you? Happy to see you. Okay. Fair enough. We could play with one, I suppose, and try and see if I can make it unlawful, but I think it's going to be kind of a pain in the butt to do. Although I guess we can just pick a if there's already an implementation of state, we can try and do this. If you want oh, okay. If you want to make sure that the order is correct, I see what you're saying. So there's probably no law. And Oren, just give me 1 second, and I will recap what's going on. So there's no law that enforces the order for an applicative, but in Monad there is a law that enforces the sequencing. I don't know which one it is, but that it must be that way. We'll write that. Let me write that now, actually, before I forget. Okay, so here, the order which we get A and wonderful, and B is arbitrary. Applicative does not guarantee order. However, monad does. Okay, so Oren, we are basically working on exercise 6.1 in Book of Monads. So we literally have gotten about, well, not about, 5 paragraphs in, and we've spent already an hour on that first bit. So it basically gave us the functor instance, and it's asked us to generate the monad instance. World's Ender had brought up that there's not a lot to read, basically, not yet anyway. So World's Ender pointed out that you can actually take the following functions. One, also the tuple operator, and this function and this unit tuple and group state with the following data constructors. Actually, we probably need these in scope, don't we? These need to be this, right? Wait, I can't do that. What am I doing here? These need to be new types, right? Ah. Okay. At least I think they do. Well, I guess you can specialize on S as well, right? But we'll just write them as new types because I'm trying to get in the habit of that anyway. We just have a few extra constructors to deal with, but totally fine. Oh, I still need S. Right. I can't just write that. That doesn't work. It's very obvious after I finish writing it. Right, because I need to do F maps. Do you prefer run or un? I noticed, I mean, you probably prefer un. I'm not sure if there's any reason to use run or un in this case, but I've seen both, so I'm not sure what people... I mean, they're functions, so like, you apply functions. So should it be apply app? I don't know. But you're not actually applying it. I don't know. Un is shorter. Done. Solution. We did it. So I mean, it's basically copy and paste of this functor instance, yes. All right, I can deal with that. Just gonna make this a little smaller for a second. Expected type. Oh, it's not the same. Right. Because we don't have, we don't need to save S. There we go. The top one is the same, in fact, so. And then I'll get rid of GHCID. Okay. Am I supposed to use these functions here? I suppose I can. I mean, I don't really need to, though. Maybe I need to. Not need, that's not the right term. Oh, I'm not supposed to have an S there? Oh, right, because that's just state. It's supposed to flip them, though, right? Or is it supposed to maintain the order? I mean, I guess you're gonna have to flip them at some point. Well, that's okay. It's just right. If we do it the other way, then I can't do a functor on A, which is what I'm trying to do. Yes. That's no worries. You're helping me a ton. I really appreciate it. I'm just thinking out loud, and you're typing, which is a lot harder. Okay. So what do we need to change here? So we're not going to get rid of this, or we are going to get rid of this, and then we no longer have this. We just have a tuple. So we need to. Yeah, otherwise our functor instance doesn't make a lot of sense. We could probably just get rid of this. So SAS is just this. And we need to apply F to just this. But we can't use fmap. Is there another... I know there's a by map, but is there a first map? I don't know what to call it before I write it. I mean, I guess I don't need to write it. I can just do this. Just save myself some time, yeah. Be smarter than the computer. Be one with the computer. Okay. Control arrow. That's one of the ones that we haven't played with yet that we definitely should play with. So yeah, I mean, this is just a pattern match, so we'll just use that. There's probably more complicated. What is that character? That does not show up as anything on my computer. I don't know if that is supposed to be something. My app definition can probably, yeah, probably. So here, Nice. I suppose this can just be a dot as well, right? Oh, no. It can't. Because this is really the piece that's the S. So I need a dollar sign there. Ooh. See, like, that's why I need a new chair. My back it's rough in this one. But this chair does look nice. Okay, so let's get back to explaining to Oren what we're doing here. Because we've gone on quite the excursion. I like it though. I hope we're gonna learn something. I think that World's Ender is putting us down the right path, so I like it. We're gonna simplify our everything. So like, this one. Actually, let's leave it up there. So I'm gonna write your name in here. I hope that's okay. What should I call this? A neat result from mathematics? Simplify the implementation of state? What do we think about? Does that make sense? Or should I write, is this really category theory? Oops, wrong button. There we go. So there's a naive solution. Okay. There's a neat result from category theory. To simplify the implementation of functor, applicative, and monad. The remainder of this code will attempt to use the knowledge. I can spell, I swear. So there's the naive solution, and actually I would really like to write the naive solutions, all of them, and then we'll do that later though, and we can come back to these. So let's put a comment here, and then comment all of these lines. And then let's do the following. Okay. Does this kind of make sense to everyone? How am I doing? I think I'm doing okay. I do want to just implement the naive one, but I think it's pretty close to this, more or less. We just, pretty close to that. We just need to change our variables. So from here, we can now write instance functor state s where fmap F okay, so water. Cheers. Um, okay. After you give the ice, oh, I see. I see what you're saying. So now I need to write the the for lack of a better term, I'm going to call it isomorphism, which is going to take a state SA and turn that into a app s tup SA. I see what you're saying now. The term isomorphism, I usually get that, but well, it's still weird. We technically only need one way, right? Ow. Okay. So I don't hate sat. Um, State app whatever. Okay. Also, there's two more viewers from what we had before. I think I'm not sure if it's just catching up. MoveUp might be catching up, but right now we are trying to learn a little bit of category theory from World's Ender. I'm not saying we're really learning category theory, but we're using some stuff. We're using some rules or mathematics available in category theory to simplify the solution of implementing functor, applicative, and monad for state. Although one could probably argue that this is not as simple, but that's okay. It's definitely more interesting. Alrighty. So to construct an app, I just need an S, and I need to produce an A. Well, I need to produce a tup. So to do that, I need a tup and an A. I'm getting quiet again. I'll read that in just a second. I want to finish this. Okay. The advantage is that you shouldn't need to think at each step to verify the correctness after you're done writing it, instead of having to follow 2 to 3 let in or whatever. My train of thought here, we have an S to tuple AS that makes us an app S tuple AS, which we can fmap tup to get our app S. Fmap tup and fmap. Oh. Oh. Interesting. Interesting. Oh, I don't want to look at that. Wild. Yeah, I think it was just the type checker was just taking too long to catch up with my typing. I see what you're saying now. It took me a minute to like, because I'm writing it as let in, like my brain is in let in mode. So, but now that you show me this, I see what's going on, right? So we're embedding our function s to as, which is really just a arbitrary a. So we just stick that in app and then fmap our tuple into it so that we get app of tup of le. What's the $ on line 50? This one? 45? Sorry, Swarm, I'm not sure which one you're talking about. Or is it one I deleted and I'm just a little behind? Oh, okay, I deleted it. Sorry. I can go back if you want. Also, hello. How are you, Swarm? Oh, it just looks like a $? I can make it a little bigger. This one? I'm not sure which S, but anyway. You can't read? It's a problem. Yeah, I think he just misread something. Alrighty. So let's see here. Hmm. It's the other way. I think I'm thinking about something wrong. I need fmap. Yeah, Swarm. This is weird for me as well. We're working with World's Ender, and I like it. I think I'm learning stuff. I just need to think about this. So I need more f mapping. So if I haven't. Okay. I think I need to. Huh? Right, because I have to untuple the thing inside app and then pull it back out. Also, hello, new viewers. There's 7 of you now. How is everyone? If it's unclear what we're doing, don't worry, because it's a little unclear to me. But we're essentially using some, what did you call it? There was a term. We're using some category theory from World's Ender. I don't personally know category theory, but there's actually some news about that. But I'm gonna let you know later. I forgot. I can't find the name. You gave a name. Something. I'll find it. Adjoint functor pair. Okay, so that comes from category theory. We'll put it in parentheses here. Adjoint functor pair. Can I like format this? Hell yeah. Love Vim. Adjoint functor pair. Is that correct? Where'd it go? That. Okay, I lost it. I'm not gonna look very carefully since people are just hanging out. So this is a theory or a result of category theory, and essentially it's going to allow us to simplify the instantiations of the functor, applicative, and monad instances for state. So essentially we're going down that path right now. So what you have to do is you basically generate 2 constructors, which we've called arbitrarily app and tup. That's probably not a good name for them, but we can change them later. I don't know what to call them, so I'm not too worried about it. Oh, applicative is different. Okay. Well, we need to implement applicative first, so... But that's okay. Yeah, okay, so what we're doing is we wrote the functor instances for both of these, and now we're writing the isomorphisms between a state and an app composed with tup. That's not the right term. An app with a tup inside of it, okay? And the reverse. And essentially they look like this. They're actually pretty clean. If you have questions about these, feel free to ask me. I think I'm understanding what's going on here, but we haven't gotten to the point where we're actually implementing the functor instance. So hopefully we'll learn something when we do that. Okay, so now what? Now we implement this? Yeah? Ah, I see. Okay. I'm guessing we're doing this. Okay, I'm not thinking about this right. I think isn't that what I'm doing here? F is just an A to B function. So if I have app Okay, I need to close the door. Hang on. So, World's Ender, you mentioned true, but why does I need to figure out why this doesn't work? But first, we're gonna have a discussion. So you said write point free for extra points. So, because in this channel we have something that we like to call piffs off. Okay, and basically what piffs off is it stands for point free for the sake of point free. And our little buddy Hodor really likes point free. So Hodor is the golden squirrel and protector of the realm, and he writes in point free notation. So we'll let Hodor take this one when we're ready. He goes up there. We're gonna use him as the stream's mascot. So I haven't gotten to getting all that taken care of, but I still need to understand why this doesn't work. Interesting. So I really need a double. Yeah, no, that makes sense. Because I have to get in here. If I can't get in there, I can't do it. So the only this doesn't okay. I mean, I guess I could maybe get rid of this F, but I'm not gonna try and do that. That's too much for me. I think that this is probably okay. I mean, kind of. I'm not sure how I feel about it right now. So it's like one of those situations where it seems like we're doing a ton more computation, but maybe we're actually not. Like it looks like it's more complicated because we're doing these sort of surrounding convert to something else and then convert back. It's interesting, right? That you can write this. I definitely agree that it's interesting. The reason is that this stays inside the category. I can't wait till I understand what that means. So actually, I'm going to announce this now because there's 10 folks watching, and I think that some folks will be interested in this. Maybe just World's Ender. So, hang on. Do one more thing. So, let's just announce this now because I think it's going to happen. So, I have this book now because, as you guys know, I love books. So we are going to do this on stream, but we're going to do it a little differently than we've been doing the other books. What we're going to do is do a book club with my local functional programming meetup group. So I don't know when we're going to do this yet, but the idea is once a month, it's not very often, but once a month, not during normal stream times, we're going to go through chapters of this book and have discussions about it with the local FP group. And obviously all of you are welcome to join. So that's the plan. I want to double check with Bartos that we can actually do that, but this thing is under Creative Commons. So in theory, it shouldn't be a problem, but I like to ask anyway. So if anyone's interested in that, wait for some details and we'll we'll do that. So I do want to understand a little bit about category theory because it seems interesting. So that's kind of what we're doing right now. So everything here is easily inline, and oh, that's a good point. So the new type removes a lot of this overhead that like is sort of, it's there in sort of the noisy text, but a lot of it gets optimized away. That's a really good point. In fact, maybe there's really no difference between this one and this one when you're done, like when you're all said and done with things. That's a really good point I didn't think about. New type's pretty great. Okay, cool. So now we are on to, oh yeah, so I guess I'll say one more thing about that. If category theory is not your thing, or you're not interested in being part of that book club, then we'll just, I mean, we're gonna do normal Haskell streams like we always do, so it won't get in your way. It will just be something else that we're doing simultaneously once a month. So if you're interested, you know, you can get the book. I'll have more details about this soon. We haven't worked out all the details, so that's coming. Basically, every time you use a constructor or destructor of a new type, it gets compiled to the identity function. Yeah. I didn't know. I think I know that. Okay. So I think I know that. Now we write this one. So pure. Wait, what am I doing? I'm just trying to get that instance written, so I don't have to worry about this. Okay, so for pure, it was suggested that we need, what do we need? Oh, it's not, it's really an X. I mean, we don't need any of these functions, right? It's just pure is the same. Put a space there. Oh, oh, okay. So you could do, um, so unit tuple gets us that, and then we basically state const x I see. Okay. So unit, oh, it's not const x, that's not right. It's, what is it? We basically need to replace this piece. We need unit tuple and fmap, he says. Or she, I apologize. It assuming gender in 2019. I should probably turn that into a command. I say that a lot. We need unit tuple and fmap. Okay. So what are we trying to do? Let's make this undefined and write some types. So we have unit tuple. Okay. So it's really state unit, oops. And then we does this work like I think it does though? I mean, this works, right? This is correct, I think. You're saying I can simplify that. That's fine, but I think that this is technically correct. Yes. It looks wild. Isn't that what I had? Oh, well, I didn't have state. But this is essentially the same thing. I mean, you can prove that. Mmm. Interesting. I gotta look up the definition of this. So that's okay. Cool. Sometimes I forget that these things exist, so I like when adjoint tells me them. I probably should have looked at the type of this before I did anything, because it probably would have been very obvious that I would have had like, I mean, if we can just look it up on Google real quick. No, it was a $sign. Right. It's basically const a f b f a. So it's essentially const in a functorial context. This has been very fun. You're giving me some sort of, not mind melting, but it's definitely some interesting type machinery. Apparently the people disagree, but I don't disagree. All right, next. So what is this thing? This is going to be f state and I assume I'm going to use the ISO here, right? Although you mentioned I'm going to use group state and something else. I think it was group state and probably apply if I had to guess, because this is kind of what we have. Yes. Okay. I think that's what we're probably going to do. Maybe we don't even need apply. So yeah, I think I think that makes sense. Okay. Yeah, see, when I look in here, this is where I feel like I need apply, because A is really going to be, well, it's going to be A to B. It's not really apply. It's going to be A to B. Well, it is apply, isn't it? The one thing we do need to do is pull state out of these. I'm pretty sure. And really, this just becomes a function, and this becomes, we're going to say, I think, state. No, I think I'm doing this wrong already. I think that I need to fmap group state. I don't see it yet. It should come to me. I mean, I can change it if it makes. So I mean, by you saying that, it makes me feel like I do need ISOs here, right? But you said I don't need apply, so Oren says, "Whoops, can just use fmap, right? Maybe. What do I fmap? That's the part I don't see. because like this is gonna end up being, if I, okay, so let's say I group state these two things. So I would write, I guess, right? But the type of this ends up being, I think, oh, okay, I see what you're saying. I see what you're saying. I think I see, but maybe I do. I mean, that's literally the piece that we need to make this work, right? So you just need to take this. No. Give me a second. Okay. So now I have essentially this, but where this A is really an A to B, and this is really an A. Okay, hang on. Well, you can, but then pattern matching is needed for first and second. We won't be able to use the generic function group state. Oh, did I actually have it? I don't think I had it. I mean, I see it. That I need to apply to that. I'm such a moron. I'm stupid. I'm sorry. I I was like, I need to put this here. Oh, that's an F map. Duh. I'm trying to F map in the wrong place. Okay. So yeah, I do need to, because of the shapes of group state and apply, I do need to pattern match here and then re-embed state. So if I write F map, I can use a $, but I don't know, is this more readable? Maybe. It's arguable. I totally see it now. My brain was just stuck for whatever reason. Okay. Neat. Wouldn't that be cool? That would be nice. Honestly, though, new mate, I think that looks a little ugly. I think it would really look ugly. Like if you did this, like I don't think that would look good. I think that's actually kind of hard to read. Maybe it isn't, but I don't know. I mean, if you really want to use $, you can just write. Yeah. Yeah, if group state was written such that this just said state, that's its state, that's its state, it would be a lot easier. It would just be apply fmap group state fsas sas without these. But it's fine. This is what we wrote. So we'll deal with it. I don't think it looks that terrible. I get it now. I was just being an idiot. Sort of my normal state. Okay, so what we're gonna do is we're actually gonna write the monad instance and then we're gonna be done. We didn't do anything in the chapter, but we learned some stuff and I think we had some fun. I had fun. So next week on Tuesday we'll have to do this again, but that's fine. Oh, so return pure. Then I assume we're also going to need to pattern match this. This is going to be. Oh no, this is going to be an FA. Okay. You've read the 5 paragraphs? It took you 2 hours? I'm joking, obviously. None of this, by the way, is in the book at all. So this is kind of all. We're gonna have to probably sit down and write a bit of this. Oh, I have this backwards, don't I? Function of A to state. Let's just do AS to save time. Okay. Now we need more ISOs. Okay. So if we need ISOs, that implies that I can get rid of that. And we're going to do something like ISO sat sas and something. Yeah. Well, I need to get rid of that actually if I'm going to use ISOs, right? The chat might be just really slow today. And then we're going to need this. And we need something in between. So FAS is oh. This actually embeds a state, so I don't need the un-ISO. I only need ISO sat. And I just need to return. It's gonna look something like our functor instance, more or less. I think. Let's write the type here. Hang on, I want to do something. I really want the type of this. Oh, I had it. Okay. Oh, I guess I don't. I think I only need one. No. Oh, I need apply here. So cat air. Oh, give me a second to collect my brain. Okay. So I want to get to this A. So that would be an F map, F map. But then I need to just pull this stuff out. Right? So don't I just need to untup, unapp, and then stick a state in front of it or something? I'm gonna try that. We're gonna take a state. We need to except that's not quite right because this needs to be I want to try this. It's probably wrong, but it's going to make me feel better in the long run that I tried it. Oh, well. That doesn't even give us a B, which is interesting. Hang on, Kitty's gonna leave. Sorry about that. Freeman, how's it going? Hosting with 7 chatters. Insanity. Hello chatters. Feel free to, I think you can say hi if he's hosting, or do you, if you're hosting, I think maybe you still chat in the, you still chat in Freeman's channel. I actually don't fully understand how hosting works. But thanks for the host. Okay, we're gonna start with fmap, iso sat dot pass sas. Whoa. Oh, okay, good. I was gonna say. So what's the type here? Please show me type. Oh, it doesn't work, so it can't show me the type. Maybe it can. Okay. Peel this off, and peel that off. So, okay, you're saying turn this into a state and then peel off the outer state. So it's like, I hate this. So, okay. I need to get a different apply. Maybe it will help and make more sense. So this is supposed to be app s tup sa to a. Is that right? Type rodeo is pretty tough here. I mean, clearly we're gonna do this, but let me. Right. I just want to get type checking working again. I think I get it now, because if this is just B, then if you just can pull the B out, you're basically done. Wait, really? Oh, right. I got you. Because of this. I get it. So I can't F map. Stop complaining, I know. I can't pattern match that out. Wait. I always do that backwards. Pretty sure this is right though. It's not. Huh. So if we untup this, we have that. Where A is this. So why am I so confused? I'm too tired. I'm falling apart. So if we untop, we're probably not doing what we're supposed to be doing. That's probably what it is. Although, why does this seem like it should be right? It's so annoying. Why do I only get this state back if I un it's not, gosh. I mean, I tried that before, but I'm getting to the point where I'm fried, I think, because my brain's not working. Right? ASA is exactly what we want, isn't it? Ugh. Wait, really? Oh. Probably this. Okay. This is what you're looking for. I presume this is right. I dot what? Dollar equal dot? Confused. You're gonna have to explain that more, or and I'm lost. My brain has no, like, its context is gone. We need to be done. That's okay. We're almost at the point where we got this. So now the real question is what does that get me? Oh, right. Oh, I see. I got it. Dollar sign is dot. Um, right. So the shape is actually backwards. Let me look at this again. So applies shape is the other way around. Why did we do it that way? Fmap. I think we're supposed to be using this, but its shape is not what I expect. Or was the point that if I see this, this should make more sense? Is that the point? Because it's really just, you just flip these two things, I think. Now we can collapse the inside of one apps. What? Now we can collapse the inside of one apps. I don't understand. I mean, if I have this function, isn't it just trivial? Isn't this the function I need? I'm gonna comment this for now. I mean, that's not right, but how do I collapse the inside with this function? I can't sequence. Do I need some sort of apply? As in applicative? But I think I'm supposed to do it with just functors. Is harder. Why the second question? Why the question marks? I'm super confused. You've thrown me off. I'm sufficiently confused. But it seems to me that I need this function, not this function. But like, looking at this looks almost like, I mean, like a sequence. But we don't have reversible, so it's not like I can do that. You've stumped me. What? Oh my gosh. What nonsense is this? That's wizard's magic. Humans come up with this stuff? My goodness. I would have never thought to do that ever. Oh my gosh. Okay, let me just write this solution down and think about it a lot. You're hurting my head. Oh, let's get rid of this. This is absurd. Okay. It's not absurd, obviously, because it works, but so this becomes state s app s tup sa. Yes? So we turn that into this. So you have, well, sorry, B. That becomes app s tup sb. Yeah? I'm sorry, I really didn't see that. I didn't even think about like double isosat. I would have never expected that. I mean, I guess it happens because you have to be able to unwind it, right? The only way to unwind it is to stack apps together. It's the same way the monad works. Yes. So, you have to be able to embed an additional structure and then get rid of it. That's why you need two isosats. Yes. Because if we were just writing the normal monad instance, we would just embed state and then flatten. But in this case, we're converting it to a state app. So we need to unroll the inner piece and then the outer piece. I think I'm saying that correctly, but probably not. Or, well, okay, it's actually, I'm sorry, let me say that more. We're unrolling or converting the outer piece so that we can flatten. And that's what the apply tup is doing, is flattening this inside piece here so that we can convert it back to a state. Am I saying that correctly or approximately correctly? I hope so. This is it. I think that it makes logical sense. We're sort of emulating the extra embedding by doing this second isosat such that we can flatten. Okay. It's way late. So the only other thing I have to ask, because now I'm very curious, how does this help me in the future again? Like, this is generic? In what sense? How is this generic? Does this work for any monad as long as I can define the isomorphisms and these functions? Obviously, the shape of group state needs to change, but you're essentially going to have a version of apply, unit, and group state. And once you have those three functions, as well as the isomorphisms, you have all of your instances, right? Is my chat dead? I feel like I'm saying a lot and no one's responding. Could someone Discord me if the chat's actually dead? I don't think it's dead. Not dropping frames, connection fine. I think people are just quiet. Also, active fireball. Okay. So yeah, this was wildly interesting. I'm not sure what it means though, completely. Oh, we haven't finished this either. Ugh. Let's finish this real quick. and then I don't know. I have no idea to say. We played a lot of type rodeo, that's for sure. Type rodeo is fun. Did it get the embedded ones right? Yeah, it did. Good. So now what we want to do is just quickly write these and call it a night. And by these, I mean this. And we really want state. This is going to be FASB. And no. Something like that. I assume we're going to use something like this, where we get F we really need an extra state in here, don't we? I'm gonna go with CSI Kate. Thanks so much for the follow. Really appreciate that. We're streaming pretty late tonight, but I think we're almost done. So this is gonna take an S and make a new state. So this is really gonna be, but it needs an A. So it's really gonna be A S1 SAS S0 and then we need to get a B by taking FASBS on A. That gets me a state of B, and then applying that to S1. This gets me, oh, right. I need to pull the state out of this one. So I need to run it. Right? or I mean, that's it. So it's just this. I'm overkilling. Right? Now I haven't actually checked the rules here, but I'm pretty sure this is right. So this gets us our state of B. We just run it so that we can apply it to our new state and then wrap it in another, well, wrap it in state. So that's it. So one thing I've never thought about doing, which is perfectly reasonable, is just writing pure here. Shouldn't that just get us a state? Why can't I do this? Why do I need state there? Shouldn't I just realize that I want state? Why doesn't that work? Oh, right. Because pure takes a value. Yeah, that's why. And embeds it. Okay. Anyway, I think that's it. So for today, we need World's Ender. Are you gonna be here potentially next Tuesday? Maybe we can talk a little bit more about this. I would like to. I don't know. World's Ender is going quiet. That's okay. Yeah, we're done. Okay. We did a lot of stuff, but we didn't get through the chapter at all. So, but that's fine. We'll play more with the chapter next time. We did learn some stuff about category theory, I guess, or at least we learned some stuff about category theory, I suppose. And we did some fun type rodeo type stuff. And I really enjoy that kind of stuff. So uncomment this for, well, I don't know. What do we want to uncomment? Is it this? Or the naive solution? I think we really want this. For now. Excuse me. Okay, so reminder also for myself. Oh, exercise 6.1. Implement functor. Okay. So let's move this down here. It's not really simplify. It's like a different set of functions that you need to define all three of them, but maybe simplify is fine here. The remainder of this code will attempt to use the knowledge. The remainder of this code is used to implement that concept above side the break. The block is the naive solution. Is that good? I think that's pretty good. Okay, we're done. Let's commit this code. All right, so for anyone that's never been here before,